Okay, chapter 6, this is your practice quiz. So in number 1, we had a few things. Number 1 was asking us to find the mean, the standard deviation, the median, and the IQR for an existing set of data, but has been transformed in a certain way. Let's just, for a second, look at how they transformed it. We've got 35 plus 73 times the value that we're plugging in, right? And this value is the number of credit hours that we're working on, right? And so if I want to convert, it says, suppose they charge 73 for a flat rate of 35 per quarter, and then if they're taking credit hours, you have to multiply them by 75, right? So here is the average number of credit hours, the standard deviation for the number of students, and all of the 5-number summary here. They want us to convert this over. When we figure this out, when I add 35, what do we call that? I heard it. Shifting. That's when I add or subtract a number. I have to be careful about that one. That one doesn't always work. It doesn't always affect things. What do you call it when you multiply by a number? Rescaling, right? Multiply or divide by a number, it's called rescaling, right? And so measures of what aren't affected by the $35? Any measure of spread is not affected by adding the 35. Now, to find the mean and all the values like that, we're literally going to do 35 plus 73 times the original mean of 16.65. In this case, I'm literally going to plug those values in. So we're going to get $1,250.65 or 45 cents. Because it's a measure of center, I can make all those changes take effect. However, with standard deviation, with the original standard deviation, it's 2.96. Because we are only we don't apply shifts to spread, we're only going to change that by multiplying times 73. In that case, you're going to get 216.08. Most people, if you're going to make a mistake, most people will make the mistake here and here because they're going to plug it into this formula and not even think about it, right? It's a simple little thing to do, but keep in mind that anytime I make a measure of spread, I'm changing that. If I have some type of addition or subtraction when I'm converting original statistics to something in a new statistic, I'm going to only apply those measures of rescaling, the multiplication or division. What's my new median? 35 plus 73 times 16 is going to be that new median value, which is going to be 1203. Here again, measures of center. I'm just going to plug in IQR. They didn't tell me IQR, but we can find out the IQR pretty easily, right? The IQR, what's the IQR formula? Q3 minus Q1, so 75% minus 25%. Be careful of saying percentages. You might think, oh, it's 50%. Well, that's true, but the IQR is an actual range of values in context. So this is going to be 19 minus 15, or just 4. So here we're going to do 73 times 4, which is going to be 292 for the new IQR. And that's it. These are very computational things, but you can't just plug it in. You have to know which one works. All right, let's move on to number 2. It says 28 credit hours. Seems like a lot, and it's a crazy amount of credit hours. If you ever take that many, I feel sorry for you. How do we say that it's actually too high? We're going to use the outlier formula. 28 credit hours, so really Z equals X minus the mean divided by the standard deviation. Oh, no. Let me back up. Getting ahead of myself. We're using the outlier formulas, right? So we'd like to use the higher end, Q3 plus 1.5 times the IQR would be equal to my upper fence. This will tell me if I've got something that is a little bit too far out. And so we know the Q3, what was that value? Q3 is 19. So we're going to say 19 plus 1.5 times 4. And it turns out that I believe that's around 25, right? And so because 28 is beyond 25, we can say that that's an unusually large number of credit hours, right? We would consider this as an outlier, right? An outlier. All right, let's look at number 2. And this example, this is actually really simple. What they want you to do is they want you to kind of draw the normal model, right? And so in this case, we're going to start up. We're going to be at 100 in the center. I'm going to kind of break some values down. I'm going to go 1, 2, and 3 standard deviations. So this would be above by 1 standard deviation. So we're going to do 115, and then 130, and then 145. If I go down by a standard deviation, we're going to go down to 85, and then 70, and then 55. This is not quite enough for me to get credit for this question. In order for me to do this, I have to also have the values broken up. I can do it in general like 68, 95, 99.7, or I can break it down into its individual components. For this problem, since I'm not being asked to use this anymore, the 68, 95, 99.7 is going to be the easier route. But if I had been asked in the future questions, hey, what is the percentage between these values? And if I'm going to be using this, I'm probably going to want to put down those individual values inside, right? So here, within 1 standard deviation, we know that that's 68% of the data. If I go out 2 standard deviations, this is 95% of the data. If we go all the way out to 3 standard deviations, we know that's 99.7% of the data. And that would get you full credit for a question like this, right? Also, if I had kind of labeled the individual 34 here, 13.5, 2.35, and 0.15, that would also get you the same credit. Okay, that way is a lot more useful if I need it in the future and for future questions. Any questions about this one? Definitely have that 68, 95, 99.7 rule memorized. It's not on a formula sheet anywhere. Question 3. Here it's giving you 2 different dogs, right? It's saying one, you have a Dalmatian, so the mean for the Dalmatians is equal to 50 pounds. The standard deviation for the Dalmatian is equal to 3.3. We have a boxer, so we have the mean for the boxers, which is 57.5 pounds. We have the standard deviation for the boxers at 1.7 pounds. The question is, one statistics teacher owns an underweight Dalmatian and an underweight boxer. The Dalmatian weighs 45 pounds, the boxer weighs 52 pounds. Which dog is more underweight for what the expectation is for that particular dog? And this would be useful if I knew how many standard deviations below the mean something is. Right? I can't compare apples to apples here because I have 2 different things. I have to compare the dogs to itself, right? They have 2 different averages. They have different spreads. So the way we can make comparisons between different groups, between a situation that looks like this, one that looks like this, is we have to standardize the values by making a z-score. Okay? So the z-score for this side is going to be 45 minus 50 divided by 3.3. And for the boxer, we're going to have, 52 minus 57.5 divided by the 1.7. These values are going to get me some negative z-scores. We know those z-scores are negative because these values are all below my mean, and it's going to create a negative difference, which is expected in this case. If I do the Dalmatian, it's negative 1.52, and the boxer is negative 3.24. In reality, when I look at these values, the Dalmatian's underweight values here, not really even surprising. It's 1.5 standard deviations below the mean. And we could find the probability of that happening, and that wouldn't be very much of a surprise to you. Like, it's not common, but it's not rare in any instance. However, once we look over here, we see that this is almost 3¼ standard deviations below the mean. That would give me something to think about. If my dog isn't supposed to be miniature or anything like that, this signifies there's something possibly wrong. That your dog is so underweight that the chance of that happening is almost zero. If you have a standard sized dog and they're this underweight, right? That's extremely small. You could even find the probability of doing that, right? The way we do that is this is not part of the problem, but it's good to look at. What we see here is, here's my mean for the z-scores, it's 0. And down over here, we have a z-score that's equal to -3.24. And I want to find the area to the left of that value. What's the probability? What's the chance that I just randomly get a dog that is underweight, but is a normal underweight dog? In other words, they're just kind of miniature, if in the case that they're not supposed to be a miniature. I'm going to go to my calculator. I'm going to use second VARs. I'm going to go to normal CDF because I want to know the percentage, right? So we're going to go normal CDF. This is not part of the question, but it helps us to explain normal CDF, kind of what's coming up in a minute. Normal CDF of -1E99 with a upper limit of -3.24. What's the mean for the z-scores? 0, and the standard deviation? 1. That is a thing. These two right here, that's only for z-scores. And it's always a thing. If I want to work with z-scores, whether I'm using inverse norm or normal CDF, I can always use those values and work it out. The chance of this happening is 0.000598. That's the probability. If I were to randomly select a boxer from a selection of boxers that are supposed to be standard sized boxers, the chance that I could pick one that's that underweight would be extraordinarily small. All right. Speaking of probabilities and areas under the curve, this brings us to question number 4. Here we have a question about body temperature, about thermometers. And it's giving you an ear temperature, ear thermometer, right? It's one of those infrared thermometers. The question is, an ear temperature of 97 degrees may indicate hypothermia, low body temperature. What % of people have ear temperatures that may indicate hypothermia? Okay, and so here, if I draw a curve, we know that the average temperature for using an ear thermometer is 98.7 degrees. So somewhere down here, we have a 97 degree temperature. How do we know that I want to find the area below 97? What gives me that idea? What is hyperthermia? It's when your body cannot keep the temperature up where it's supposed to be, and your body's temperature begins to drop. If it drops too low, you will lose consciousness and eventually die if you can't keep that temperature up, right? And so we would like to know, given this situation, what's the chance that somebody could have a temperature below 97 degrees just randomly? That's probably not a good, it's probably not a very high possibility. Because we're looking for probability, area under the curve, I'm using normal CDF, right? We have a standard deviation here of 0.7. So we're going to use normal CDF. We're going to use -1E99 again, up to 97, with a mean of 98.7 and a standard deviation of 0.7. Because I have this picture, I don't have to define any of the numbers in my list here. However, if I had not drawn this picture, then those numbers over there, I have to define them. It's so much easier just to draw the picture. It helps you to get your mind around where you're drawing, what area you're trying to find. It defines that for your grader that you do actually know what it is normal CDF is about to give you. If it's just random and you're not really paying attention, then you're going to have to be careful about that. In this case, we're going to say We're going to plug that in, and we're going to get it's 0.0076, I believe. Is that right? Okay. The key is going to be a little bit different because you have, if you're looking at the key, you're not going to have the same value as 0.0067. It's going to be 0.0075. The key uses a different method. Instead of using the calculator, it's using the z-scores and the standard normal table to find this area out. The calculator is always going to be more accurate representation. Notice they're really close. Either method would get you full credit. But you notice the difference in explanations. With the table, I had to kind of go through a little bit more explanation with z-scores and things like that. So be careful. Either method's good, but you have to provide the support to get those answers correct. You can't just throw down the number. In fact, if I just saw this number with no support at all, I'm probably going to mark off 3/4 of the points because, like, no, you got to do more than this. In fact, some AP questions would give you 0 credit for that, right? They want to know how you did it, what you did to get there. When we're looking for the interquartile range, what we kind of have to write down what we know. We know this, right? We've got a normal model. We know that that model has a center of 98.7, and we said that here's Q3 and here's Q1. What we do know is that the distance between the two is considered the IQR. We also know that that area is the middle 50%. Given that that's true, what area is this? What percent of the area is this part right here? 25. How do we know that? The two sides on the outside are symmetric. So that means the remaining area, the 50% that's left over, is going to be located in the tails, right? Out here is 25 and 25 here. How do we use, you said earlier that we use inverse norm to get the values. Then how do we do it? Okay, back up a minute. Can you tell me why you used 0.25 here? Excellent. The first quartile, Q1, is that value. I can do the same thing again, but this time use 0.75 and 98, 0.7 and 0.7, and that's going to get me Q3. Right? And so we do this when we plug the inverse norm 0.25, 98, and 0.7 and 0.7, we get Q1 to be equal to 98.22. And we do the same thing for Q3. We're going to get 99 point what? Anybody? 99.17. So, yeah. If I subtract these two, Q3 minus Q1, we're going to get 0.944. If you looked at the answer key, that's not what you got, was it? Why is that? The answer key was using the table. It used the z-score of 0.67, and it looked it up using that estimated z-score. Very close. Both methods would get you exactly full credit, right? There's nothing wrong with it. We use the inverse norm. This is much more accurate than the table is. The table only gives you 1/100ths in terms of z-scores, right? It only gives you 2 decimal places. We were using, well, as many decimal places as the calculator allows, which is quite a few. And so we're going to get a little more accurate result with our numbers here. So sometimes, especially when you're working on quizzes like these and I give you a key to it, if your decimals are a little bit off and it looked like they looked up something in the table versus you using the calculator, definitely going to see some slight differences in your answers, and that is perfectly okay. If you use the table or if you use the inverse norm, your work supports your answer. In other words, if you get something that I didn't, something's wrong with it, I'm going to rework the problem using your information. If I can get your numbers to show up and give me what you got, no big deal. Totally fine. right? As long as you use all the right numbers. If I can find the mistake, then that's where you'll lose points. If your numbers give me something different, you just typed it in wrong or something, then that's where you lose points on it, right? So make sure you give me that result and support it with whichever way you did it in, all right? Not that either way is right or wrong. Okay, next part. Part C, and this is the part you're going to kind of pay attention to. This one's a little tricky, and there's a number of ways to do this. I'm going to kind of go the direct route that I don't have to kind of be too creative about it. They tell us the IQR is 0.5, right? So that makes me think, well, Q3 minus Q1 is 0.5. That tells me that if I can find Q1 and Q3, I might have something I can work with. I need the standard deviation. So far, the only formula that I can think of that uses the standard deviation in a problem is the z-score formula. And so I'm going to have to think about that. What we do know, let's just say it this way. What we have set up, kind of come back to this, and if I had this drawn on another part of the screen, I might not redraw it, but at this point, you guys can't see all of that. So 98.7 is here. We said that here, we know that Q1 or Q3 is above the mean and that Q1 is below the mean. Last time I did this, the z-score was really important, right? Because I can't really work all this out. Either I find out what Q3 is, then I work it out in the problem up top and kind of hold on to it and work it out from there and solve for sigma, solve for the standard deviation, or I do something else. We know here's 0.5. Then what is Q3's value? We can figure that out, right? Right? We'd say 98.7 plus 0.25, right? Because half of that value is above and half of it is below, because the mean in a normally distributed set of data falls right in the center between Q3 and Q1. It's the 50th percentile, right? Right, so we end up getting, what is that? 98.95 is equal to Q3. So let's try this. I haven't tried this one this way. And so we're going to 98.95 minus the mean of 98.7 divided by the standard deviation equal, what's the z-score for the top Q3? How do you find that out? Z-scores can be found using inverse norm like this. So the z-score for Q3 be found by saying inverse norm, where we have 0.75, 0, and 1. Notice these. Z-scores only. Okay? Because we have a value I want to go back to, if I know the percentage, I can use inverse norm to go back and either give me that X value, in this case it would be temperature, or if I use 0 and 1, it's going to get me a z-score. That's going to be we'll round it to 0.67, because that's what the book does. Okay? So I can go in here and say this is 0.67, and I can do that division, or subtraction division altogether. So we can multiply that out. Well, it turns out that we'll end up getting 0.25 divided by 0.67 is equal to standard deviation, which that turns out to be equal to 0.373. I did it a couple of different ways today. I think this way is probably the fastest, the most succinct way to get to the right answer. We took this distance. We knew that this distance from here was 0.25, and this distance here was 0.25. We know that because the IQR itself is 0.5 across. Now, be careful. That's a really bad choice of numbers, right? 0.5 also means 50% as a proportion. Those are two different things right now, okay? I am not using percentages. In other words, 1/4 of a degree above and 1/4 of a degree below the mean is where we would get Q1 and Q3, okay? Does anybody have a question about how we go from here to here? And that's it, really.